So, you want to know how archaeologists accurately plot and map their finds? Well, the answer is simple really. We use modern digital surveying technology to plot our finds in 3 dimensions using X, Y, and Z coordinates. This requires the use of one very sophisticated tool that we call the total station, or as it is more commonly known, a theodolite. As an optical surveying tool, the use of a total station depends largely on both the context and the environment in which it is being used. Though put simply, it can be described as a spatial tool that relies upon a fixed GPS coordinate system to plot points within a given environment, ranging from its use in civil engineering projects to its more common application in the mining industry. The total station has proven to be both time-efficient and accurate. This is especially true when it comes to its application in archaeological contexts, where it is used to both geospatially orientate important archaeological research areas, as well as plot exciting archaeological finds in 3 dimensions. And so, without any further ado, my name is James Davey, and today I'm going to take you through the steps of setting up a total station for use at an archaeological excavation site. The site we're at here is Milner Hall West, which is the name of one of the cave chambers located at the Sterkfontein Caves World Heritage Site in Johannesburg. This new and exciting excavation represents a new chapter in Sterkfontein's research history that first began with the work of Robert Broom in 1936, and to this day remains one of the world's richest fossil-bearing locales on Earth, attesting to South Africa's place in the story of humankind. Aided by the use of the total station, any potential finds can be accurately plotted and used to formulate an accurate geospatial dataset. To use the total station, we must first and foremost set up our tripod, which will be used to seat the total station device. The legs of the tripod must be evenly spaced, and it must be positioned in an area that allows for a good line of sight to be established. As with any piece of sensitive equipment, we must carefully unpack the total station device, which is housed in a waterproof and shock-resistant case. From here, the total station can be seated on the tripod and fixed into position using a bottom-mounted attachment bolt that is located beneath the tripod platform. The 2 batteries must then be inserted on either side, and only then can the device be powered on. Before we can begin shooting any points, however, it is important to make sure that the total station is perfectly level. This is achieved by rotating one of 3 adjustment screws that are found at the base of the total station in a triangular formation. The adjustment screws at the front, where the camera is facing, adjust the pitch of the device, and the 2 adjustment screws at the back adjust the yaw, or the left to right angle of the device. Once the device has been leveled, using the analog spirit levels built into the total station, fine adjustments can be made using the digital level that is displayed automatically whenever the device is being set up. We then enter the total station setup menu, where the appropriate geospatial reference file must be selected. From the Setup Station menu, you must then input the total station's height from the ground. This must be measured from the center point of the tripod to the top of the total station. By looking through the periscope found on the side of the device, the tape measure can be accurately centered, and the height can then be inputted. Measuring the height is important because all points will be shot in relation to this reference point. From here, we must then spatially calibrate the device in relation to 2 reference points, known as our resections. These reference points will create a fixed position for the total station, which is important because all the shot data will be recorded relative to this position. The device will not only measure the vertical, horizontal, and slope distances between points, but will further factor in the height of the total station device, the distance and the height between the target being shot, as well as the vertical and horizontal angles between the total station and the target. The first reference shot here requires the use of a mini-prism, which is essentially a series of mirrors that are angled to form a prism. The infrared waves from the total station hit the reflective mirrors, which angles them towards the center point of the mini-prism. This is held in place by either staking the prism into the ground, or as many held in place by one of our colleagues, in both cases, making sure the prism is level. To guide the total station into position, the laser pointer can be activated, and once near enough to the target, you can peer down the scope and adjust the resolution accordingly. Making small adjustments left, right, up, and down using the fine focusing knobs located on the side of the device, the first shots can be taken. A series of 3 shots is taken in succession, and once completed, this establishes one of our 2 calibrating resections. The second calibrating shot here does not require the use of a mini prism, and as such, the setting must be changed from the input menu to show that a reflectorless surface is being shot. This is not always necessary, but in a cave environment such as this, one of our reference points is located on the cave wall. The same steps are followed as with the first shot, and you can see here, illustrated by the laser dot going on and off, when the total station is taking its shots. Once both of the shots have been taken, we can then view our errors and make sure that our device is calibrated properly. We are now ready to dig in and collect our spatial data. This data can then be inputted into a geographic information system, or GIS, such as ArcGIS, and used to plot our data points on a map, illustrating its position in 3 dimensions. These illustrative maps are vital to provide us with insight into the context of a given environment, as well as the depositional placement of archaeological material, referring to its position in the ground. In conjunction with manual data collection methods using a datum, the data collected from the total station can further be displayed digitally in relation to a fixed coordinate system. Think of a Google map, where you can add pins to highlight where something is. The only real distinction is that instead of highlighting just one area, the total station allows us to plot and display many points in 3 dimensions. Thank you for watching this tutorial video, and happy surveying.